I'd like to introduce Laurie Raymer. He's Principal Consultant with Resourceful Paths, and he's got over 20 years experience in operations, project and technical management, and consulting. He's a multidisciplinary and system-based problem solver and is triple bottom line focus. He aims to grow economic value, reduce risk, and build internal capability for his clients.
Okay, thank you very much, Adrian. All right, so welcome, Alex. You've all heard from Alex now. We got Andrew and Emily. Unfortunately, Russ isn't here, but he's with us in spirit, and he did give us a few notes, and I'll probably share a few comments from him as appropriate, because he did have some really useful insights. So we'll make a start. We'll just ask each of you to introduce yourselves, starting with Emily.
Hi, just before I introduce myself, you're all probably wondering, why is she wearing those glasses? So they're actually augmented reality glasses, so that when I go underground, I can look at the rock face and get all sorts of interesting information, characteristics about it, and local conditions of oxygen levels and particulate levels. And no, actually, I just got laser eye surgery. But anyways, maybe I'll come back in a few years with some really cool, real virtual reality or augmented reality glasses. So yeah, my name is Emily Thorne-Corte. I run my own company, Thorne Associates, an energy and carbon management firm, and it's just brand new, a few weeks old. I left Hatch as the Director of Energy Optimization and Management this summer, and worked there for 9 years. I continue actually now. I'm also a Certified Energy Manager Instructor, so for any of those who are interested in that, and on the board of the Ontario Society of Professional Engineers, and worked prior to that in fuel cell industry. Happy to be here.
Thank you. Andrew?
So good afternoon to all of those of you who are still here. My name is Andrew Cooper. I'm the energy specialist at New Gold's New Afton mine in beautiful British Columbia. You can probably tell from my accent, I'm not originally from here. I'm originally from Bulawayo, the second largest city of Zimbabwe. And listening to everyone up here today, it's truly amazing how global energy management has actually become. New Afton was actually the first mine in North America to be certified to the ISO 50001 Energy Management Standard. And since our first full year of being certified, New Afton in 2014, New Afton has achieved in excess of 31 gigawatt hours of savings. In terms we all understand, that's in excess of $1 million a year in energy savings costs. And this was driven largely by very, very good people, the support of a very good management team, and on the back of a very, very good data-driven energy management information system.
Thanks. Yes. Yeah. Thanks. Alex.
And hi, folks. Again, Alex Smith with Cisco Systems. I think I've already been introduced, so let's get going.
Excellent. Thank you. All right, I'd like to start by asking each of the panelists, what are the key building blocks of a leading-edge digital and data-driven mine energy system? So starting with you, Emily.
Sure. So I think, Laurie, there's a few important building blocks. One of the trends that we're seeing is into cloud computing. So I think that's an important building block as we go forward. I know OSI SoftPi has a cloud version. Internet of Things sensors is also very important, as is a EMIS, an energy management information system that's linked to your other business processes, such as your maintenance management system, production, et cetera. Also, on a more, I guess, human level, looking at process change maps for the data, it's really important before you embark on any kind of new data initiative to identify all of the key stakeholders from the miners at the mine face up through to the supervisors and the mine managers, and identify, who needs which data and get it to them, and not more, so they don't get overwhelmed, as well as training people. And then I think about further out, the augmented reality joke was actually true. I do think that will play a building block in the future. For example, if you imagine the design of greenfield mines, and you think you could make a model. Right now, engineering consulting firms have 3D models, but you can't go in them, right? So if you have an augmented reality or virtual reality, you could actually be in it. You could actually do training, and I think it could be quite powerful to have some miners who are down mining every day, get them to come into the augmented reality models and help the design engineers make some more realistic changes. So I think those are some of the building blocks that we can use for data systems in the future.
Excellent. And we take the point, remember the people, it's not just about the numbers. Yep. Andrew?
I think, Alex, in your presentation, you covered off a large number of the building blocks for an essential data system. And just to build a bit on that, I think sensors that give you accurate and repeatable data. It's pointless getting data coming into your system if it's not accurate and repeatable, so we find that calibrations and checks to make sure that is the case. Efficient storage and retrieval. If you're storing the data, you need to retrieve it, so have efficient storage of data. And one thing that people overlook when talking about an energy management information system is networking. You can have meters all over the place, and that was one of our biggest challenges, was actually installing the networking to connect all the various different types of meters and relays, etc., that you have over the plant. And good energy model development, predictive analysis, building good energy data models to allow you to compare performance, current performance, and predict future performance and see how you're performing against that.
Excellent, thanks. Alex?
Yes, I won't try and repeat anything that you just heard in my previous presentation, but I'll introduce one topic that might be a little bit new as a potential component, and the general term for it is edge analytics. And that's a concept where you can embed really close to the devices themselves, to the sensors, some intelligence so that you can do some things in real time. And that might be, by the way, filtering. If you've got a flood of data that's coming from many, many different types of sensors, all into, let's say it's into a cloud environment, that's going to cause an impact on the network, on the cloud, the compute resources, et cetera, et cetera. And so the concept is that put some intelligence perhaps in the network itself, so that you can filter the data and also see that if a temperature reading is normal, then you can just send an average every 15, 60 minutes, whatever you think is appropriate. But if it goes above a certain policy range, then that's something that you don't want to get a report on next week. That's something that you want to be acted on potentially in millisecond time. And so the concept of doing a component of analytics at the very edge of the network can be beneficial.
Okay, and I think that sort of speaks to the architecture perhaps is changing as new technologies are emerging, so thanks. Okay, we touched on data. You mentioned it already, how much data, Emily. I'd also like your thoughts on, are mines measuring too much data, too little data? How to best manage that, especially as we're generating more?
Sure, yes. In my experience with mining companies, from an energy perspective, there's still too little data. Perhaps in productivity or production and stuff, there might be an overwhelming amount of data, but in terms of energy, when we try and look at the submetering and actually go for the benchmarking, thank you, Michelle, for a great presentation, then we find that we're still could benefit from more, I guess, drill down data. So I would say in terms of digitization, if you're putting in an energy management information system or improving the one you have, the best practice as per NRCan's EMIS planning manual and tool, which is excellent if you haven't read it, then is to use energy account centers, which are basically cost centers, and to have data in terms of for blasting, for drilling, for mucking, and that kind of thing to do that. So, and yeah, that would be a way to say.
Any comments, Andrew or Alex, on that?
I think we went a bit overboard in terms of submetering, but in hindsight, it's been a blessing. We've been able to measure all sorts of things, stuff even from as our power for reagent addition to right through to our grinding circuits. it's proved very valuable in the long run in terms of energy projects, having data available for identifying energy projects. I feel as long as you're measuring the variables which affect energy performance, the variables which impact energy performance, whether it be your production rate, whether it be temperature, pressure, flow, whatever it may be, as long as you're monitoring those in a good, efficient way, which will help you calculate your energy models, I think that would be a critical thing to look at and understand.
Okay, so it's really relevant data that's driving energy consumption, for example, yeah. Any other comments, Alex?
The only thing I would add is just that because you have the potential of accessing so much data, you may want to be particular about, start with the business outcomes that you want to achieve, and you may not necessarily on the first step want to be looking at everything, because could be a challenging task. So start with the outcome first, or the theory that you have, that if I analyze this, I think this is an outcome, I could save energy, and then work backwards in terms of what data do you need out of the huge amount of data that you could potentially collect.
Thanks. Many mining companies are setting more ambitious climate change goals, reducing gas emissions, greenhouse gas emissions, etc., and that's linked to the energy mix and consumption rates. How important do you feel digital innovations are in achieving those climate goals? Maybe start with you, Andrew.
You start off at a mine, our focus has been in particular elimination of waste. So I know we had a renewable conference and clean tech and all the rest of it, but our primary focus has been elimination of waste. We don't focus on renewables because, hey, if we're going to generate renewable power, then just waste it. So I think Mark Passy, was referring to the energy you don't use is the best type of energy. So the data in what I see is being data to optimize process. Once you've achieved all the efficiency gains you can, and it becomes expensive, very expensive, your paybacks for implementing efficiency measures start getting too long to become acceptable, then you start using data to optimize processes. You have the data in place, and you can use that data to process optimization, visualization, and find your efficiency gains that way. And I think there are big savings to be made in the mining industry from doing that.
Excellent, thanks. Emily, any comments on that?
Sure, yeah, just absolutely echoing Andrew and Mark Passy about the greenest kilowatt hours, the one you do not consume, to properly eliminate the waste before putting in the renewable energy. I think digitization is going to be a real key for productivity improvements, right, which are on an intensity basis. At least you're going to help with your climate goals from an intensity basis. And one of the things in my experience working with mining companies that is not well understood is the true energy drivers within a mine. I think the Coalition for Eco-Efficient Comminution out of Australia has some excellent tools, and again, benchmarking for comminution. Great, again, with Enercan's now helping, but you can see there's a number of factors, and I don't think that the mining community fully understands that. So I think digitization is going to help us unpack all that so we can have clear sort of models that'll help in that.
Okay, so really using the data to understand the drivers, it echoes Andrew's point.
And when you understand it, then you can better manage it, which
Yes.
will help your climate.
Yes, okay. Thanks. Andrew, we'll move on and talk a little bit more about some specifics of the energy savings that you've made at New Afton. Can you perhaps share a little bit about some of those achievements?
We look at energy savings from the perspective of what has the energy management information system help us identify.
Yes.
A good example would be our underground compressed air system. We were tracking the underground compressed air and underground compressed air energy consumption. And from checking the energy performance indicators on a weekly basis, it was running along nice and steady, and next thing it just went completely south, and we started losing a lot of energy, wasting energy. That triggered an investigation, and after just a few days, we found that the one compressor wasn't offloading properly and was putting out a ton of power for very little airflow. If it wasn't for the EMIS in place, we might not have identified that until the next major service, maybe a year later. So we caught an energy waste of in excess of $73,000, which would be worth a year, in a week. And that's just an example of, one small example of how a good energy management system is helping you identify problems and catch them early.
That's great, yes, and definitely catch them early. That's really important. I just want to talk about ventilation on demand. It came up yesterday, and both Emily and Alex, you've had some experience in that area, so I'd like maybe to touch on that. Can you perhaps quantify some of the savings and how digital aspects came into those, achieving those savings in ventilation on demand? Alex, you want to start?
Sure. I can't speak in a great amount of detail, but ventilation on demand is one of my favorite applications because in a number of mines, for a number of different companies, that was the initial application that cost justified putting in a Wi-Fi network to an underground mine. It was something that they had kind of felt that it was putting Wi-Fi would probably be beneficial and probably have a bunch of different applications, but they didn't jump onto it until ventilation on demand put in, I think in one case, a 12-month payback period for the entire project. And that's not just the network infrastructure, that's all the process control, developing application, and so on. So I'm a big fan of it for that reason.
It's a good result. 12-month payback is a pretty exceptional result. Emily?
Yes, I would agree with Alex. We did a ventilation on demand study that the client then implemented and saved about $2 million per year. So the savings can be really substantial. I mean, an underground mine, ventilation can be 40–50% of the energy cost. So it's typically number one. So it's really important to look. And you can there's different levels of ventilation on demand that you can do. So depending on the economics of your particular case, you can choose how far you want to go, shall we say.
Yeah, and the impression I get is that data is very important because you absolutely need to know both how the efficiency of the system is working and that you're ventilating in the right areas where various people and assets are to manage that. So would you agree that the data piece is critical in successful implementation of that?
Yeah, absolutely. And I mean, ventilation on demand, there's a huge safety aspect too, right?
Yes.
I always say safety is, I'll say safety is king or queen. So you don't want to mess with safety, right? Usually energy, it's usually always after production, definitely after safety, right? So.
Yeah, and I think we can agree that the data-driven mine is very much also a safe mine and an environmentally sound and social mine. All right, I'm just going to touch on OSI Pi. This came up a little bit earlier, and it links into also with Barrick. Barrick invested heavily in that platform, and it was for data historian, trending, various aspects. And they justified it on savings in their oxygen plants and their other process plants. They looked at some opportunities and said, this is going to identify opportunities. Andrew, you also have the Pi system at New Afton, so I'd like you to talk perhaps a little bit about that and how it's helping discover opportunities for energy savings and so forth.
We were very fortunate when New Afton started production that our process engineer had organized to have Pi installed. And that was a blessing in disguise. It's formed the backbone of our entire energy management information system. I could talk for ages and really get excited about what it's done for us, the functionality, but it enables so much. We do all our model analysis in there, all our predictive analysis, our overconsumption event reporting, our notifications, our visualization tools. There's so much that's driven by Pi, and it really has enabled us to do so much and be very effective in our energy management system and the models we put in there.
Excellent. And Alex, I understand Cisco is a partner with OSI as well. And do you have any comments on how a system like that helps and fits in?
We've the edge analytics concept that I'd mentioned before. OSI Soft is a partner of Cisco in that realm, and so they take appropriate slices of their Pi application and embed that into the network to help supplement the a more decentralized and more real-time analysis capability.
Excellent. I had a couple of comments from Russ as well. The site that he works at, Red Chris, they don't have the PI system, they have another historian system. And his comment as well is, these systems are important. They obviously help various engineers discover the data to support or justify a change, but ultimately it's still the engineers that are making the decisions about where are the improvements. So it's really hand in hand, you need both. So that was a comment from Russ. Emily, did you want to add anything on the PI area at all? Okay, we'll move on. I want to start, Alex, with you on real-time data and predictive analytics. That's something, there's a lot of talk about that, and we're moving towards that. There's potential for energy efficiency, perhaps higher renewables penetration, other opportunities. Can you maybe talk to that aspect and how that fits in?
Yeah, and again, I'll probably jump back onto the edge analytics topic when you use the term real time in the question. And, I do think, analytics is absolutely critical for digitization. That's making, data into information that can be used. And it's the analytics that does that. And there's components that make sense to centralize and correlate, and there's components that you may want to push down to, close to the sensors themselves for the real-time aspects and reaction to a trigger event, let's say.
Yeah, obviously in mining it's very important that we don't have events that cause major shutdowns or safety issues. So, Andrew, any comments on that? Anything that New Gold's doing in that area?
We constantly trending against our best past performance. So we have models which predict what the energy should be under a certain set of circumstances. We track and trend against that. And if we have any deviation from that, we investigate why, and then we implement measures to improve our performance to where we were before. We're taking that a step further going forward, and we're looking at doing this next year. We've already started working with folks from OSI Soft in this regard, is breaking our mill down into the different components of the mill, then analyzing all variables in that particular section of the mill, whether it be grinding, the regrind circuit, the tertiary grinding circuit, the flotation, the tailings, whatever section it may be, looking at all the inputs into that, not only energy, all the outputs from that, and analyzing those in what Pi calls event frames, those little slices of time. And we'll be able to track performance around a specific part of the plant for 5, 10, 15, 20, 30-minute intervals, and anything goes off spec, its operators will get notified. And we were looking at incorporating machine learning from Microsoft as well to try and get the process to learn from each other, learn from itself, and get better and better, and get model analytics get better, and better improve our operator reaction to changes in the process. And that's what we're looking at doing, using Pi and real-time data going forward.
Okay, well that sounds exciting, and we hope it leads to some real benefits. Emily, I think you mentioned models earlier as well. Can you perhaps share some views on that aspect and how that fits in with the predictive analytics, etc.?
Sure, yeah, real-time data and predictive analytics. I just want to say it's great the work that, Andrew, you've done at New Gold. I would say you're by far a leader in the mining industry. Most of the clients that I'm dealing with haven't already had many sort of years of experience with EMIS, and so I think if you're just starting out on your sort of predictive analytics journey on the energy side, then something as simple as just having predictive weather for your global adjustment, energy pricing in terms of seeing if, I don't know if it's often it's not possible, can you hoist at night, or other kind of batch processes, other energy pricing. And one of the things with the alarms, I think we had talked about earlier, is to be careful with the operator overload, right? If they're getting too many alarms, you have to think even from a safety perspective. So I think that was something that, so those are some of the more simple predictive analytics that you can do.
Yeah, that's good, and I think that also aligns with a couple of comments from Russ. Russ's company doesn't have a huge amount of funds right now for investment, but his comment was, there's quite a lot you can do with certain basic data management systems, etc., and trending to make some good starts and really do what you can, get the best system you can afford, etc., to do these kind of predictions and so forth. All right, I'm going to ask Andrew, for you to talk a little bit about some future technology, ore sorting technology that's happening at New Afton that kind of links in with the concept of the mine of the future. It's something that helps reduce energy consumption and waste production, etc. And recently, I understand you've installed that. Can you maybe talk about how data fits into a new process innovation like that, how important it is to optimize that and justify it, etc.?
I'll do that first. A disclaimer: I'm not a guru in this field at all, but I know that we're just installing ore sorting on our underground conveyor coming to surface. The intention is to determine grade in the ore coming from underground. But our director of mining could probably speak far better to that than I can. But the whole objective is, okay, what's the grade of this particular part of ore? When it gets to surface, if it's waste, we'll divert it so it doesn't go to our stockpile. If it's intermediate, we'll divert it to intermediate grade pile. And if it's high quality ore, it'll go through to our stockpile. We then improve our efficiency by not processing lower grade ore or waste and getting rid of it as it's coming up the belt. And that the data from that will help us determine what's the best grade of ore to use. We can then relate that ore grades on the belt to our assays and see whether our assays are online, whether the ore sorter is online and the specs are correct, and improve our efficiency, operational efficiency overall of the mill. And that's really the objective of it.
Okay, well, that's another exciting opportunity, and clearly data is very important to make sure you're actually making those right process production decisions. I want to touch on cloud computing again, just for Emily and Alex to perhaps talk about that, what role you see for cloud computing in a data-driven mine, and any limitations or pitfalls. So perhaps if we start with Emily and then Alex.
Sure. So to date, again, most of the mining companies I've worked with, their OSI SoftPy or equivalent system, data historian, has been on-premise, but there's lots of efficiency savings that you can be gained from having cloud computing, and energy savings at the data centers and emission savings as well. So that does certainly seem to be a trend. There's Microsoft Azure system, Amazon AWS, and this means less infrastructure for mining clients. So you're just going to basically have your sensors in the field, and then you can have data transport via satellites. We're working with one client who's rolling out an EMIS system globally, about 15 sites, and so it can have actually just the sensors to local hub and then to global hub via satellite.
That sounds very space age, but exciting. Alex?
Yeah, I think cloud is going to become increasingly important. And someday, I don't know when in the future, but we'll probably end up in a model much like we have with electrical utilities, where computing and so on is not something you do, it's something you consume. And that is really what cloud promises, and what it brings to companies is the ability to be much more agile. And if you need a bit more intensive computing for something, you just turn up a knob and you get that, and you didn't have to run around and figure out how you're going to build it yourself for that spike in demand. So that's the real benefit, and so I see that as a really long-term trend. But some of the realities today are mines are not in cities. They're in very, very remote places with difficult, challenging, they could be on the side of a mountain with some shaky microwave towers going down, and all it takes is a bit of bad weather to put your connectivity at risk. So that would be, a near-term limitation for certain sites to go to a fully cloud model. But there's emerging technologies being promised, such as low orbit satellites and so on, that will have much more reliable, low latency, high bandwidth versus today's satellite links that are low bandwidth and high latency, and make them not very appropriate for real-time, applications like teleremote or autonomous vehicles, for example. You can't do that over a really long latency getting back and forth.
Okay, so that seems to be a key point, understanding how the communications aspects, etc., fit in. Hopefully satellites will fix everything in the end, but we'll see. And I like the point about the latency because for certain processes they move slowly, and as long as you intervene at an appropriate time, everything's good. But other things that are where you need to make a decision instantly, obviously the speed is very important. Okay, I just want to ask, how long does it take to set up a leading digital system, perhaps from a base of a well-functioning mine? What resources are needed? What can go wrong in the design and implementation? What are some of the key pitfalls? So probably a question for each of you. If we start perhaps with Alex.
Sure. I'm going to jump onto my my culture topic as the leading cause. You know, I don't think technology is going to be people's issue to digitize. There's lots and lots of technology options out there, lots of examples on how to do it. But I'd say the culture aspect is the one that might bite you behind and cause it to be a failure. Okay,
and certainly culture can obviously drag out the process if it's not favourable, yes, innovative. Yep. Andrew, any comments?
It's one of those depends.
Yes, that's what the metallurgists say. I'm a metallurgist, but anyway.
It all depends on the complexity of your mine, how many meters, how much relays do you have in place, how well are they connected. From the get-go at New Afton, we were a brand new mine, we had just started production. It took us about a year to get everything properly connected up and hooked up, running, and the models set up. So it was quite a lengthy process for us, and it took us a fair amount of time, but we work closely with, there's so many people who are involved, from IT. You need to have the support to do it, the backing to do it, and then you need to have people on site who know a bit about energy so that you're putting the system to good use.
Okay, so key people who understand how everything fits together seems to be a theme there. Emily?
Sure. So in terms of timing, we highly recommend conducting an EMIS study ahead of time. It'll also help you in terms of when you're going to your board or your executive for approval in terms of the return on investment if you're putting in a new EMIS system. So that study's maybe 3 to 6 months, depending again on the complexity. It definitely does depend. And then for implementation, typically I would say 6 to 12 months. In terms of the people, we typically say you need sort of 3 types of people. So yeah, of course you need the sort of IT systems and software and hardware people who understand the meters and the specifications for those, but you need an energy person such as myself who understands ideally the sector as well in terms of mining, who can help with the functional specifications and also act as a sort of user who understand the user's needs and even can conduct user training initially and even testing of the software. You don't really want to have your IT people who developed to be doing the testing. So, and then also process people who understand the process as well. In terms of some of the issues you said we've seen, I mean, it depends on a case-by-case basis. We had one site, it wasn't actually a mining site, it was an industrial site where their single-line diagrams, they had said, yes, we have all this data for you, and we had assumed this, and there were major issues with the single lines in terms of the meters were either not there where they said they were, or there was new ones. Anyway, so it took actually a couple months extra in terms of the schedule just to get the single lines updated. Also, lack of resources. We had energy manager who left, so that's always difficult to manage. But and then some issues with programming the meters, the different types of meters. And this particular client went for a cheaper type of meter. I think in retrospect, it would have been better to go for the more expensive. I don't like to, I guess, say too much good things about, or bad things about vendors, but I mean, Schneider Electric certainly is, with their ion meters, I would say, one of the leaders in the industry, and they chose a different one anyways.
Andrew, yeah.
One thing I could add is we did a lot of retrofitting after the fact when we installed our metering. When we came to do our tertiary grinding expansion, we designed everything in. We spec'd it into the design, and it went in at a fraction of the cost. And if you get the opportunity to design in for expansion, new builds, it really does save you a lot of money over trying to retrofit it later on.
Yeah, Emily? Yeah.
Yes, so absolutely agree. So doing an energy design review that encompasses digitization and encompasses energy management information system, even if there's one already spec'd out, to actually review the specifications, see if you can improve it is critical, and you can see some large savings.
Absolutely. So really thinking ahead, thinking to the future, how can you plug in these new innovations, etc. Yeah, you don't want to start again from the ground up if you locked out some of those options. And again, thanks for mentioning the people. I think that's really important that we think about the users. Just want to touch on security. Alex, you mentioned this. Perhaps if you could maybe talk about some specific examples of security issues that need to be managed as mines move to more digitization.
Yeah, it's a very broad topic, and there's lots of different types of threats. You really want to try and find some intelligence, and there are tools out there to baseline and look at what is happening in your environment today. And I'm talking not in the IT, but in the OT environment. What's normal, and actually go through and make sure that something unusual is not happening, that, like I said, there's not a video surveillance camera that's talking to a ventilation process controller. That's the kind of thing that should stick out to you when you have the right tools to look at. And then once you have that baseline, things are a lot easier to just, red flag me whenever something moves off of baseline and starts behaving in a way that's suspicious. That, some machine I have is trying to, make an internet call to a different country that, that my company doesn't operate in that company or that country. So, that would be off baseline and should be alerted to someone that cares about that system.
Good, thanks.
So baselining is a great place to start.
Excellent. Emily, do you have any comments on that as well?
Sure, yeah, I'm not a security expert, so address all the hard questions to Alex, but I guess if I was advocating on behalf of a miner, I would just say, look at the key access points that people can get into your system, whether that's the sensors, if it's cloud-based, look at all the different components and push as much responsibility as you can onto the cloud vendors, so it's their business to keep your data safe, so they should be the experts. You're trying to mine, ore out of the ground, so I would push as much as you can onto them.
And I'd just make a general comment that this, it seems like this should be part of a normal risk management process that mines are using. We do risk management on all other aspects.
Yeah, that's a great point. I think all mining companies have risk management departments, and I'd say this is starting to become a board of directors level of issue and awareness, which is great. And yeah. Nothing further to add.
Okay, well, we're just going to ask a final question for each of you. What do you see as the most critical success factor for implementing digital technology for future mine energy management? And we'll start with Emily.
So I think the most critical success factor is related to any energy management success factor. It's your CEO. And how much she or he cares about this is going to really influence your culture and how that, if it's important to my boss, it's important to me kind of philosophy, right? And I think Alex talked about mining perhaps not being one of the most innovative or in terms of cultures. I would say that there's definitely some companies that I've worked with which are extremely innovative and done some really great projects, Glencore, for example. But if other companies are looking to have a more innovative culture, of course, diversity is going to help with that innovative culture. So that's another key. So diverse culture and get the CEO to get on board.
Okay, all comes from the leadership. Andrew?
I had a co-op student about a year and a half ago, and this guy just absolutely blew me away. The youth coming up today, their skills, their knowledge, their ability to deal with data and data-driven systems is just phenomenal. In fact, my last co-op student, I actually went and organized a computer science co-op student because things have changed to such an extent that I'm looking for computing science skills to help me with my energy management as opposed to typical to engineering. So I think key people, knowledgeable people, people who can manage data or are used to working in that environment, have the skills to do that, are key going forward.
Okay, good point. Hire smart, hire people who are young, energetic, and know about this stuff.
And are way smarter than me. Yeah.
Yep, it's okay to hire smarter than you. All right, Alex, we'll finish with you.
Two quick points. One is back on culture again. I'd say there's actually two ways to drive change of culture. Probably the most effective and fastest is to have it go top down, and I've seen that work very well. When the CEO says, we're going off in this direction, and you're either on board or you're out, that tends to drive change. But I've also seen success at a more grassroots level where the caring middle manager or even someone who's at the bottom layer is getting buy-in. So I guess I'm saying there's two ways to get buy-in is needed in order to collaborate. So you can either drive it from the top or acquire that buy-in through collaboration and common understanding and all the good grassroots things. And I was going to expand quickly on, sorry, the last thing that you said. No, I've lost it.
It's okay. All right. I'm just going to share a thought from Russ. And his comment was success equals pre-planning. And his comment there was that some of the changes that he's seen in his experience where people have rushed in, perhaps they've just kind of done a very rushed transition, put everything into a big box and hope that people will just work it out. That doesn't always end up achieving your goals. You do need some planning. I think that was touched on as well, Emily, by yourself. So success equals pre-planning. Well, look, that's the end of the panel, or my questions to the panel. I think we have time for a couple of... Oh, sorry, that's the timer going off.
No,
There we go.
No, we're good. Arnold, can you cut?
Yeah. Hello. Sorry. Hello. My name is Arnold. I have my own company, R4 Mining. I'm mostly focused on training, and I am the responsible of the workshop of energy and mines. My question is related to security again, and security related to the blockchain era. We, in the last months or the last years, we know about cryptography and cryptocurrencies and so on. But especially, I'm very much interested in blockchain in terms of security and interchange of information, secure information. So I don't know if you think something about this in terms of energy and mines. And thank you for all.
I don't have an energy example, and I'm not a blockchain expert at all, but we do have a project underway that Cisco initiated with a totally diverse group of non-mining customers around ensuring the environmental certainty around your supply chain. And how do you know that, for example, if you're using gold in a product, did that gold come from an ethical mine, or did it come from I don't know what the right word is, a
conflict mine or
a conflict
like that,
mine? Yeah, thank you. So it's so now they're expanding down as far in the supply chain as they want to work with a mining company, and so we looped Barrick Gold in to talk about how do you ensure and track all the way down so that the end product user actually has visibility all the way down to where that gold came from, which drift in what mine, on what date did it come from. Which is something that the mining company is also very interested in for a whole set of other reasons that they can track, for example, the quality and grade, and again, go back if there's some downstream issue, where did that come from? And they're using blockchain as that mechanism to securely go between all kinds of different companies that have their own reason to look at that data. Blockchain is the underlying technology that will secure that visibility throughout the supply chain.
Emily,
Sure. I think the blockchain could actually improve the security because unlike cash, or where you have no record of the transaction, right? With blockchain, you at least know the computer where the transaction was from. So in some way, you have a better traceability, right? And so if you're looking at energy peer-to-peer transactions, say in microgrids with renewables, then you could, I think, have a better, it could actually improve security. So there's potential for an upside too.
Any other questions? I think we have time for one more. Oh, there's one over here on the...
Andrew, I want to congratulate you for, I think, ratcheting up $2 million per year of energy efficiency savings. Is that right? And you have to...
Yeah, it's
Andrew?
just a little bit over $1 million and climbing.
Absolutely fantastic. What I wondered is that you mentioned that you were moving into the mill with another initiative to try and find some more savings and so on. How much more do you think there are before you'll look at renewables to, drive down the carbon descent even further?
Dean, can you ask me a sports question, please? No, it's a very good question, and one thing that's constantly amazing me is no matter how efficient we get and how efficient we think we're getting, we keep finding more and more and more. From talking to folks at OSI Soft, the feeling is we could possibly get another 5, maybe 8% additional energy savings from proper process optimization. But it's not only the energy savings, we've been working hand in hand with operational efficiencies, and I think it really puts energy management on a fantastic level when you're incorporating the operational aspect of the company as well. It's not becoming an energy thing, it's becoming an operational thing, and I think that's really where we're trying to get to, where it becomes part of the entire operation and scope of what we do at the mine.
Okay, I think we're out of time. I'd just like to thank our excellent the panelists, Emily, Andrew, and Alex, for joining us for that.